Hey guys, welcome 14.3, the Pythagorean Theorem. A lot of you guys have heard this. It's like the most famous theorem ever, like Pythagorean Theorem. Well, now we actually get to do it. Woo! Super exciting. So, what are we doing today? We'll be finding the missing lengths of a right triangle. Pythagorean Theorem deals with a right triangle, which means a triangle with 90 degrees. You also determine if a triangle is a right triangle when given the side lengths. So first we need to label the parts of a right triangle. So first we know it's 90 degrees, right? So there's our 90-degree square for the right angle. And then we have two legs, right? The two legs are attached to the 90 degrees. But then we have that one side opposite. So that side opposite, we call that the hypotenuse. These are the parts of a right triangle, a leg, and or these are the parts you have a right triangle, a leg, and a hypotenuse with the 90 degrees. What is the Pythagorean theorem? Well, we have our side length, so we're going to call the two legs A and B, and we're going to call the hypotenuse C. That's standard. We always do that. So we have A, B, and C, and then if we kind of create a square, you notice a square here on the left side, the blue, there's 9 there, right? There's kind of 9 squares inside the square. If we use the other leg, the bottom one, the green one, there's 16 there. And if we do the red, that would create 5. Notice all those squares inside are the same length. Well, if you notice there's 9 for the blue, 16 for the green, if you add 9 plus 16, you get 25. Well, if you count how many squares are in that big red one, the ones that are same size, you would get 25. So that means the area of that square, of the two smaller squares, will equal the area of the bigger square, which in essence, each side length is A, B, and C. So then we get A squared plus B squared equals C squared. That's the formula for Pythagorean theorem. I have a really good proof for it, but since we have to do distance learning, I wasn't able to get it onto the whiteboard and use it here. I had laminated things that I was going to show you on the whiteboard, but on this iPad, I can't do it, unfortunately. So this is the best that I got. So A squared plus B squared equals C squared. You take the square, the second power of each of those lengths on the bottom attached to the 90 degrees, and then it will equal the square of that third hypotenuse. So let's do an example. Find the missing length. So what we're going to do, oops, I skipped it. So what we're going to do when we find the missing lengths, first we need to identify our A, our B, and our C. Well, C is already there, so that's pretty easy, right? And then remember, A and B are always attached to the 90 degrees. So since they're attached to the 90 degrees, what I'm going to do right above 5, I'm going to put an A. Right above 12, I'm going to put a B. So I can put A right here and B right here. And then I know that A squared plus B squared has to equal C squared. So therefore, if A is 5, I have 5 squared plus 12 squared, and that has to equal C squared. Well, 5 times 5 is 25. 12 times 12 is 144, has to equal C squared. So therefore, 169 equals C squared. Now remember, I'm going to make this a little bigger. 169 equals C squared. So remember, in order to get rid of this square, we take the square root. So remember, those cancel out, and we're just left with C. And then square root of 169 is 13. So C equals 13. But we're not done because it's a length, right? Since it is a length, we have to put meters. And then we are done. That is A squared plus B squared equaling C squared. Let's go ahead and do another example. 8 by 15 by C. So what we're going to do here, we're going to label our A and our B. A and B, guys, doesn't matter. It does not matter if 15 is A, 15 is B. It doesn't matter if 8 is A, 8 is B. It does not matter. So I'm just going to put A as 15, and then B is 8, and then this is your C. So if we have A squared plus B squared equals C squared, then A is 15 squared, B is 8 squared, and then C squared. Well, 15 times 15 is 225. 8 and 8 is 64, and that equals C squared. So 225 plus 264 is 289. which equals c squared. So we need to find the square root of 289, right? So we said 13 times 13 was 169. So let's try 14 times 14. 14 times 14 is 196. So we got to go way higher, right? Let's try 16 times 16. That's 256. So let's try 17 times 17, 289. So 17 equals C. So C equals 17 feet. Notice your hypotenuse right here, that's always the longest. C is always longest. This is longest. C is always the longest. It has to be the longest. It must be the longest because it's a diagonal. It's not straight. Okay, so this one's a little bit different now. The reason why it's different, we aren't given A and B looking for C. We are given A and C, and we're looking for B. So what we're going to do for this one, I have to label 16 as my A, and I have to label 34 as my C. So as soon as this loads, I will label 16. Here we go. 16 as A, 34 as C. So we have A squared plus B squared equals C squared. So A is 16 squared. We don't have B squared, but we know C squared is 34 squared. So 16 times 16 is 256. So I have 256 plus B squared equals, now 34 squared, who knows what that is? 34 times 34, 1,156. Cool. Now, solve for B squared. It's the same thing as solving for B. So what we're going to do, we're going to subtract 256 minus 256, and that means B squared equals, well, if we subtract 256, notice the 56 is cancel out, so 11 minus 2 is 9, so we're at 900. Well, that's pretty easy, because you can now take the square root of that and the square root of that. Those cancel out, and B has to equal, well, 900. Think about it. The square root of 9 is 3, and then the zeros kind of tag along, but remember, since we're taking the square root, you take one off, right? So B has to equal 30, because 30 times 30 is 9. 3 times 3 is 9. Carry the zeros, 900. So 30 yards. E equals 30 yards. Hopefully, you guys are kind of getting this. It's kind of understanding. It's kind of clicking. Maybe you guys have seen it before. Great. A squared plus B squared equals C squared. You have to know that. You must. All right. Example 4. Which ones are not a right triangle given the side lengths? Let me show you guys a little bit of a trick. Remember how I said the hypotenuse always has to be the longest side? Well, not always does it have to be the longest side. Well, it does always have to be the longest side, but the two legs must be longer than that third hypotenuse side. So what I mean by that, let me go ahead and do share screen, and then I will do A, B, and C. Oops, that's highlighter. A, if I call this A, B, and C, A plus B has to be greater than C. That's for any triangle ever. So A plus B has to be greater than C. So I can cancel out this one and this one because 1 plus 2 equals 3, which is equal to 3. That does not work. 10 plus 10 equals 20, which is equal to 20. That does not work. So now we only have to work with A, B, and D. So that means we need to do 3 squared plus 4 squared equals 5 squared. 3 times 3 is 16. Or sorry, 3 times 3 is 9. 4 times 4 is 16. So 9 plus 16 equals 25. Yep, A works. I know A. 5 times 5 is 25, plus 12 times 12 is 144, equals 13 times 13, 169. Yep, that works. And then 6 times 6 is 36. 8 times 8 is 64. That has to equal 10 times 10 is 100. Yep, that works. So A, B, and D. Another thing you could have done, let's look at C. 1 squared is 1, 2 squared is 4, 3 squared is 9. Does 1 plus 4 equal 9? Nope. 10 times 10 is 100. Plus 10 times 10 is 100. 20 times 20 is not 200. It's 400 because 2 times 2 is 4. Does that work? Nope. So A, B, and D work. All right. Your homework, 642, 643, 2 through 22 evens, only like 10 or 11 problems, guys. Really not too bad. Maybe 12, but it's due Friday. So good job on this lesson, challengers, and I will see you guys with the next lesson. Have a good day. Bye.